Okay, this video shows you the relationships in database design, a one-to-many relationship in this case, so you can understand the logic behind database diagrams. I'm not going to use any database diagrams here. I'm using Excel just to show you what the computer does. So you don't turn this in, you don't have to do this yourself. This is just like a lecture for you to understand the why behind some of the lab assignments that you'll do for the entire course. This is probably the most important concept in the entire course. Okay, so here we go. Essentially, when you are creating a database design, you're creating a series of tables that allows you to relate information and have many reports that maybe even duplicates that information, but at the same time allows you to store that information in only one place in the database. This means that you save on disk space. It means that with the data stored in only one place, if it changes in one place, then it's changed everywhere, meaning that if anyone needs that information and to link it up with other information, because it's stored in one place, that information will always be correct in reports that you use everywhere. When you start duplicating information in a database, like having it appear in many different rows, it gets a lot harder to keep that data consistent because you might forget to change it in one place and leave it changed in another. So what we do is we create tables in a relational database that contain information, and then we relate them together so that the information about anything only exists in one place. So let me give you an example here in our first lab in this course. We are going to be relating a customer table to an order table. This right here represents the customer table. You can see each customer has a customer ID, which I think it's good practice to use the full name of the table or an abbreviation of it, plus ID as your primary key, regardless of what your lab instructions say. If you do that way, it'll make me happy. In this case, I called it cust ID, and I said it's a PK in parenthesis. You don't type that just as to show that this is a unique identifier for each row on the table. Nobody else will have an ID of 10 other than Brent Ward. This is kind of like a social security number to the database that identifies each row in the table, and that creates what's called entity integrity, because another name for a table is an entity. So we uniquely identify each row in the table so we can access it and point to it in reports and the queries we do to extract information. And the way we make sure that each row can be identified is we give it a unique number. So Arnold Pitt has a number of 11. Like, Justine Fox has a primary key of 14. Okay, so we have this customer table. That's the first table. The second table we have is an order table. Now, when a customer places an order, we give the order a unique ID and an order date. But then we also want to be able to pull in all the customer's information without retyping it, so we don't end up with having to type in Brant Ward and my phone number and all that information over here a second time because we already have it here, right? And I might type it in wrong here, and then we might have a Brent Wood and a Brent Ward, and but it really means Brent Ward, but someone wrote Ward is Wood, and that was a mistake. We want to prevent that mistake by putting the customer's ID in here. So if Brent Ward places an order, we'd put his customer ID in here. And then the database, because these two tables will be joined in a relationship, will automatically look up this 10. It'll go over to here, look up 10, and it will then say, oh, 10 refers to Brent Ward 1, 2, 3, 4, 5, 6. And then it'll automatically copy that information into whatever report that I'm interested in by looking up the 10 again, looking the 10, pulling off the information it needs, in this case the phone, and then putting it right there. You see that? And that shows how tables get related to each other. Let's just say someone else places another order, order 106, and the date of that is 5/12/2017. And that person who placed the order was customer 14, who was Justine Fox. So the database is designed that as soon as you put in the order table the number 14 in the customer ID column here, it will then go over to this table, scan it, find 14, and then it'll take Justine's first name and put it there, take the Fox and put it there, and take that and put it there. And what's cool about this is that if Justine changes her name to Smith, the database operator will just change it right here. And because this 14 is stored in this table right here, it will automatically, when it looks up order 106, it'll pull in Justine's automatically her updated last name every time it does it. So this data isn't really stored in the order table. All that is really stored is the 14. But when we need to look at it, the database will look at 14 and then pull all this information onto our screen so that we can see exactly what is associated with Justine. So this means that our data about the customers exists in only one place. And what we do is we point to it when we need it. Now, there's a few things we need to understand. One is the concept of a key. I already explained that each table must have a primary key which describes its unique identifier. That creates what's called entity integrity. And then you'll notice here the order table, it also has a primary key denoted by PK, which uniquely identifies each order in the table so that the order table has entity integrity. What makes us create a relationship between the customer table and the order table is the fact that we have in the order table a foreign key. That's what FK stands for, which means this is a column that has numbers in it that points to keys that are in another table, in this case, the customer table. And then it allows it to pull that information associated with that foreign key in the customer table over here into any query I might do or any lookup I do of what's on this order. Now, I want to emphasize this information actually is not stored in the database in the order table. It's stored in this table, the customer table for, in this case, Brent. That's stored in the customers table, but when I say I want to look at this order, the only thing it's storing is the 10, and it'll pull this information in. So that's what a foreign key does. It allows you to kind of pull information onto your screen from another table where this number is a primary key. Now, the other thing you need to understand is that in this case, the customer table has a one-to-many relationship. See that? I put one here. Each customer can have many orders, but each order can be associated with only one customer. Now, think real hard about that because this is the way it is in real life. You want your customers to place millions of orders, right? Because then you make more money. So each customer, your database is designed so that they can have many, many, many orders. At the same time, when you have an order, if I go into order 105, I want that to be associated with only one customer. I mean, when you order on Amazon, for example, if you do that, when the receipt comes to you, it only has one name on it, yours. And that's the same with the way the database is designed in this case. So that you have a one-to-many relationship. So you remember this, that in this case we have a one-to-many relationship, and the thing I want you to burn into your mind is this phrase right here. Okay, I'm going to type out this phrase here, and that is the foreign key goes on the many side of the relationship. So when you get asked to join two tables in a one-to-many relationship, for example, apartment can have many tenants. Think about it. Each tenant under normal circumstances, and I'm going to define that for you. This is a very normal circumstance we're talking about. Each tenant in an apartment complex will normally live in only one apartment, right? But each apartment could have many different tenants. So apartments is associated with tenants in a one-to-many relationship. Think about this. Also, makes and models. When you think about cars, you have a Toyota, right? That's called a make. But within Toyota, you have many different models like the Echo, the Corolla, the 4Runner, the Yaris. So each make will have many models. But if you see the Yaris on the road, that's associated with only one Toyota. I mean, the Yaris isn't, made by Toyota and Chrysler and GM and Hyundai all at once. That doesn't make sense. That's not the way it is in real life. So each car make or manufacturer, if that makes more sense, each manufacturer is associated with many models, but each model has only one manufacturer. Now, if I had said this, if I had laid it out this way, model, manufacturer, the relationship is the same, but because I made the words backwards to what they were up here, I have to then reverse these two guys too. So each model, meaning like the Yaris, would be associated with only one manufacturer, but each manufacturer makes many different models. These two examples here say exactly the same thing, but because I put the words in a different order, I had to put these are called cardinalities. I had to put these in a different order as well. Okay, so that's what we mean when we talk about primary and foreign key relationships in this case, a one-to-many relationship. Now, there are other relationships like many-to-many, one-to-one, etc., that we may talk about at another time. But for now, I want you to just understand that what a one-to-many relationship is, because our next step will be to design a one-to-many relationship. And this is a case where each customer associates with many orders, but each order associates with only one customer. And that's this little fan at the end of this is called a crow's foot. It means many. This one on the outside here is called a maximum cardinality. It's a one. This is the maximum cardinality here. This is many. Each customer can place many orders, but each order is associated with only one customer. And subsequent videos will show you how to create this. I also want to add that in a database diagram, you can see the customer ID here is a primary key, the order number is a primary key, and we will show you how to make this customer ID a foreign key that points to a customer in this particular table. The other thing I want to point out is that you've got this circle here. This means zero, meaning that each customer can have zero orders. You might put a customer in the database because they're a prospect but not have an order for them. This database design will allow that. At the same time, you see this one that's on the inside here, this hash mark, which is a one. This is saying that each order must have a minimum of one customer and a maximum of one customer. And that makes sense too. You don't want to have an order in a system without a customer because if there's no customer, there's no one to pay for it. So this diagram here was designed in Microsoft Visio, and we'll show you how to do that later. But it starts with understanding kind of how one and many relationships relate to each other so that you have an understanding of why you're pointing and clicking and why you're relating one table or one entity to another. Okay? So that's all I have for this. Review the parts if you need to that I've here by rewinding and look for other videos from me as we progress through the course.